Hello, today we are going to talk about proofs and look at some proof questions. So as a quick recap, these are a few proof strategies that we have seen before. So direct proof, let's just say that we have a statement if P then Q. For direct proof, we start off by assuming that P is true and we want to show that Q is true for the statement to be true. And for a proof by contradiction, we start off with not Q and we end up with not P. And since both of these are equivalent, it means that if we have shown this, we have shown the statement to be true as well. So for proof by contradiction, we start off by assuming this entire statement is false. And we want to show that, from this statement is false, it leads up to this statement is true. So we have this over here, but we start off by assuming that not R is true. So the only way for this entire thing to be true is for R to be true, which means that the statement must be true. So let's look at some proof examples. The first one, if n is an odd integer, then n squared is odd. Let's try and break it down. So what does it mean for a number to be an odd integer? Probably it is that it can be expressed in terms of something like 2k plus 1. And n squared can be expressed in the form 2t plus 1. So we have broken it down like that. And if we look at it, it seems like we can do a direct proof from here. P to Q, n to n squared. That seems quite doable. We can try that out. Let's move on to the second question. Like every odd number, we see an odd number here as well. And we say n is equals to 2k plus 1. Difference between two squares. A squared minus b squared. So what this proof wants us to show is that a squared minus b squared can be expressed in the form 2k plus 1. That seems pretty direct as well. I think we can try the direct proof. And just a note, it's not that we have to pick a proof technique and just follow it throughout. If we have a proof technique, if we start off with direct and it doesn't work, we can always move on to contradiction, just to look at it at a different angle and try to prove the statement. And for number 3, if x is irrational, then 1 over x is irrational. What does it mean for a number to be irrational? We know what it means for a number to be rational. A number is rational if it can be expressed in the terms a over b. It's really hard to think about something as it is a number as something it is not. So maybe we want to try and see if we can convert it to the numbers being rational. And the way we can do that is by proof by contraposition. So we can start off with not q. Not q is 1 over x is rational. And it leads up to x is rational. That seems like it will work pretty well. So we have 1 over x is equal to a over b. And we want to show that x is rational from this. And for the last one, we have square root 2 is irrational. I think we can try and start off by assuming that square root 2 is rational. Again, it's the same problem as here. It's really hard to say what a number is not. So we can start off by assuming that square root 2 is rational. And we end up with a proof by contradiction. So let's just try out this proof. So we want to start off by proving that square root 2 is irrational. To start a proof by contradiction, how we do it is that we assume square root 2 is rational. And what does it mean for a number to be rational? It means that it can be expressed in the form a over b, but with some special properties. B cannot be 0. And a and b, let's change it to n. A and b, both of them cannot have the same divider. Cannot have common . It's like how you would express a number like as 1 over 2 instead of 2 over 4 in this case. Alright. So we have this right now. So let's just try and rearrange it a bit right now. B square root 2b is equals to a. I think we can try squaring both sides because we have this square root right here. So we can have 2b squared is equals to a squared. And it means that a squared is even because it can be expressed as in terms of 2 times something. So as a squared is even. So given that a squared is even, what do we know about a? Just as a quick proof, we can think about it like we can try and predict if a squared is even, a is even. And it's really hard to start off with a squared is even to prove that a is even. So in this case, we can also use a proof by contraposition. We can start by assuming a is odd. So a is 2k plus 1, a is odd, right? And a squared can be expressed in terms of 2k plus 1 squared, which ends up being 4k squared plus 4k plus 1, which is odd. So we have proven it the other way around. We have proven that if a is odd, a squared is odd, which means that this statement is right. So from here, we know that a is even. And since a is even, it can be expressed in terms of 2k. So we have 2b squared is equals to 2k squared. And over here, if we expand it out, we have 2b squared is equals to 4k squared, and b squared is equals to 2k squared. And if we look at it again, we know that b squared is even, which means that b must be even as well. So we have these. A is even, b is even, and our assumption, what we started off with. But if a is even and b is even, it means that both of them can be divided by 2. And we started off by saying that a and b cannot have a common divider. This means that there is a contradiction in here because we have shown that our assumption does not work. So by proof of contradiction, we know that because we started off with not r, we know that r is true. So we know that square root 2 is irrational. Thank you so much for listening and stay safe.